So in this video, we're going to be looking at the parallelization workflow. The parallelization workflow. Now, imagine that you want to launch a social media campaign. So you have, let's say the Super Bowl is coming, or the World Cup next year. So FIFA wants to launch a social media campaign. And so they need a post. They want to post that, okay, the World Cup is coming. Let's just say, yeah, the World Cup is coming. They want to post that. They need to post on Twitter. Then they need to generate another post for, let's say, Facebook. Then generate another post for Facebook. Facebook. And they need another post for Instagram. And a final post or another post for LinkedIn. For some reason, the World Cup needs to be aired on LinkedIn. So they need to post on these platforms: LinkedIn, Instagram, Facebook, and Twitter. They need to generate posts for these platforms. Now, they can do this concurrently. They can do this simultaneously. They don't need to, the Facebook post doesn't have to wait for the Twitter post. Neither does the Twitter post have to wait for the Instagram post or the LinkedIn post. This cannot be done at the same time. Meaning that if we have an input, let's say a topic, we can send it to all these work nodes at the same time for them to generate posts. Yeah, we can. And we can get their outputs and post it to the respective platforms. Or we can get an API, maybe let's say a service like Buffer as an API. So we can say, okay, pipe all that, aggregate all that on the Buffer API or to the Buffer API, and let it send the individual posts. Yeah, we can do that. We can do all this. We can do all this at the same time. I'm just picking the lasso tool. We can do all this at the same time. Take our topic, which we're talking about the World Cup, send it to all these work nodes. They will all run at the same time. We can choose to use their output individually or gather it to be processed at one central point. That's how parallelization works. Parallelization allows you to execute LLM operations simultaneously rather than sequentially. So instead of waiting for one task to complete before starting the next, parallel workflows run multiple independent tasks at the same time. They can run multiple independent tasks at the same time or the same task multiple times with different criteria. So yeah, that's how parallelization works. And for this to work, you have to make sure that each task is independent. Each task starts its process and finishes it. So it is not dependent on any other task. So all these tasks, the Twitter content generation, the Facebook post generation, the Instagram post generation, and the LinkedIn as well, they must all be independent. Another use case is when you want to analyze a document based on different criteria. Probably this one is to analyze it based on grammatical correctness. This one is to check tone. This one is supposed to check whether a certain demographic would not be offended by such a post. And maybe another one to check whether it has some sort of, maybe it's like a score, like score it for on some sort of scale. So you have to make sure that all these tasks are independent. They must all operate independently so that they can run simultaneously without affecting one another. Now, what are the advantages of this type of workflow? First is speed. The very obvious one is speed, because you can generate all these posts at the same time. You don't need to wait. You don't need to wait for Twitter to finish before you do LinkedIn. You can do all these processes at the same time. You can generate all this content at the same time. You can perform all these actions at the same time. And that thing also, it helps, it kind of improves confidence, because You can compare the outputs of these operations to see the quality. You can use different LLMs, so you can actually use different LLMs to actually do the same thing. Let's say for the Twitter, for example, let's say you want to actually just generate for Twitter, but then you generate for Twitter here using OpenAI, you generate for Twitter here using Gemini, you generate for Twitter here using Claude, you generate for Twitter here using Mistral. So you generate for Twitter, you're performing the same task, but with different components, with different LLMs. So you can use it to compare the quality that is produced by each LLM for a Twitter post. Another advantage is that it can help you to perform comprehensive analysis. So you can pick different criteria and analyze a particular input and be able to actually evaluate your content from multiple perspectives all at once. Another advantage is scale. This helps you to easily scale your work by distributing it. So parallelization has powerful features that you can take advantage of. It can help you scale. It can help you generate different results that you can compare. It increases speed, and you can also test out the confidence you have in different outputs for the same task. Now let us look at two use cases where you can employ a parallelization workflow. One is document analysis. Document analysis. You can take a single document. You can use a node to check for keywords. You can use another node to check for formatting errors. You can use a different node to check for factual accuracy. And you can use a fourth node to check for tone, all simultaneously. And you can just give them scores. So let's say you have like a document analyzation tool. You put in a document and it's able to score that document on different criteria independently and all running at the same time. Everything is running at the same time. So you're getting the scores in real time. Another use case is the marketing copy generation that we just discussed. You can generate content for multiple platforms. How amazing is that? In one single go, you can pick a topic and generate content for multiple platforms. So you can basically build a mini social media manager that you can give a topic and it's going to generate for multiple platforms. And you can keep adding platforms, and you can keep removing platforms. Because there's no dependency, it doesn't break the system. You can remove Twitter today, plug in Reddit. You can remove Facebook today, plug in Threads. So everything is all compartmentalized without dependency, and you can swap in and swap out anytime you want. In land graph terms, you create a node that is going to take your input. You can even use the start node. Then you connect this to all the nodes that are going to be running at the same time. You connect them with edges to this same node. Make each node write to a particular shared channel in your state. They can write to a particular shared channel, or you can just have them all connected to this aggregator, which then combines all the outputs from the channels that these nodes write to. Or you can make these nodes write to a list also. You can make them write to a collection, and then this can pick up the collection and process every single item in that collection. But it's easier to see how this works using an example, and we're going to be doing that next. So in this video, we're going to be implementing parallelization using our social media generation example. We're going to be creating a workflow that generates content posts for different social media platforms. Given a topic, it's going to generate a post for Instagram, another for Twitter, and one for LinkedIn. Those are going to be our three destinations, and all these posts are going to be generated in parallel, that is simultaneously. Then finally, we're going to use an aggregator node to combine all these drafted posts into one output, and each output we're going to put it in a section in the final draft. So let's begin. The first thing we're going to do is import our dependencies. I've already created a file, 0208 parallelization. So let us import our dependencies. Let's get our LangChain OpenAI library. Next, we're going to need our graphing tools. So graph.graph import start, end, and state graph. Then for our state, let us get type detect. Good. Now, the next thing we're going to do is define our states and also set up our LLM. So let us go and do that. I'm going to say class overall state. And what do we need here? First, we need a topic to write about. So take that as a string. Then we need a channel for our Instagram post. Another channel for our Twitter post. LinkedIn also gets a channel. Then we'll create the aggregator node or the aggregator channel where we would have all our outputs gathered and put into sections. So we have this 5 keys or channels in our state. Let's get our LLM ready. Good. Now you may have guessed we're going to be creating one node for every single parallel operation that we're going to be performing. We generate for Instagram, we generate for Twitter, and we generate for LinkedIn. So we need one node for each of them. Now you can have an entry node, but if it is not going to do anything like pre-process the topic, then there's no need for you to have an entry node. You can just start from the start node. So we're not doing any pre-processing to our topic. We're just going to take a raw like that and send it to our parallel workers. So let's just go ahead and start defining nodes for our social media post generating functions. So we'll say define generate Instagram. Take our state. Return the same state. I was forgetting this guy. On the same state. And inside here, we're going to say generate an engaging Instagram posts with emojis and hashtags loved by the Instagram audience. So next I'm going to add a print statement, and let's make this fun a little bit. Let's add some emojis. For Instagram, I think let's put a camera here. So I'm just going to say Instagram generator creating post. This is more like a progress indicator for our node. So generating post. Then next we have our prompt, which is quite elaborate. So to save time, I'm going to copy it from the GitHub repo and bring it in. You can also find it in the GitHub repo for this course. The GitHub repo, in the notes in the introductory section, you can get a link to the GitHub repo from there, and you can copy this stuff to follow along. Or you can write your own. Yeah, you can get creative. But yeah, I'm just going to copy the prompt and paste it in. It says create an Instagram post about, we get a topic. The requirements are engaging and visual language, 2 to 3 short paragraphs, 150 to 200 words max, include relevant emojis, end with 5 to 8 relevant hashtags for the topic that we're going to be passing in. Use a casual, friendly tone because that's the Instagram vibe. Call to action. Yeah, don't forget, there has to be a CTA to engage with the post and make it perfect for Instagram's audience. Yeah. So we have the prompt, and we can say Instagram post. Instagram post is equal to llm.invoke. Invoke. Pass in our prompt and get the content. So we have our Instagram posts. Let's put another progress indicator here. Might be tedious to put progress indicators, but trust me, it will really help in visualizing the output. So yeah, we're just going to say Instagram generator, say complete. Let's put another emoji here, like a tick sign. Yeah. Good. So we have this, and finally we can return our Instagram post into the state channel. So Instagram post. Perfect. So we have our Instagram post, or our Instagram generation node. The next one we're going to be dealing with is for Twitter. Let's do Twitter. So we do dev generate Twitter state raw state return overall state and generate. I don't know. I don't think LangGraph makes use of these doc strings and putting in the functions, but I just like putting them just to help add some description. So, or just comes from good habit creating tools with good doc strings. Yeah. So, yeah, let's also have our indicator for Twitter. Can we get the Twitter bed here? Is it possible? Yeah, I still call it Twitter. Call it X all you want, but yeah, still going to call it Twitter. We don't have the Twitter logo here, so we're just going to use something close. Let's say this guy. Okay, so this is going to say Twitter generator creating post, and these indicators will also help us see the parallel operation because there's going to be race conditions. So it's not like they're going to finish sequentially or in the order that they are defined. They're not going to finish in the order they are defined. The last triggered one might be the first to finish. So they're all going to be triggered at the same time, but it might not be finished in this order. That's Instagram, Twitter, and LinkedIn. The LinkedIn might finish first. So we have this in place. But now we're also going to get the prompt for Twitter. I'm going to bring it in from the GitHub repo, and we're going to continue writing this node. So prompt copied, paste it in here. It says create a Twitter post about our topic, same topic. Requirement maximum of 280 characters, crucial because of Twitter's limits. Punchy and attention grabbing, include 2 to 3 relevant hashtags. Conversational tone, use emojis sparingly. Should spark engagement and replies, or replies. Make it perfect for Twitter's fast-paced environment. Yeah, Twitter is always charged up, so you have to be on your toes. Oh, so we have that. So let's say Twitter post equals llm.invoke prompt. Get the content. Then we can have our indicator to, I think I can just grab that from here. By the way, let me put a new line here. So let's grab this. So that here we can also say Twitter generator complete. So with the start indicators will show us when they are triggered. The end indicators will show us the order in which they are completed. So that'll be fun to watch. Twitter post. So we can return this back to its state channel as a Twitter post. Okay. Twitter post. Good. We're done with the second node. Don't worry, we're very, very close. The third node is going to be for LinkedIn. Almighty LinkedIn. So generate LinkedIn overall state and also return overall state. And there we'll say generate a professional, because everything on LinkedIn is professional. Professional LinkedIn post. Generate a professional LinkedIn post. And to kickstart this, say print. What emoji will be good for LinkedIn? Let's see. Think like a suitcase. Yeah, let's get a suitcase. Or professional. So LinkedIn, we'll say LinkedIn generator creating posts. Then we need the prompt too, which I'm going to be copying over and pasting in here. So I have that in. It says create a LinkedIn post about our topic, still our topic. Requirements: professional yet engaging tone. 3 to 4 paragraphs because we like to talk on LinkedIn. Include insights or lessons learned. Use line breaks for readability. Add 3 to 5 professional hashtags. Include a thought-provoking question at the end. Definitely want to generate comments. Focus on value and professional development. Make it perfect for LinkedIn's professional audience. People like us. Yeah, like us that use LinkedIn. So LinkedIn post equals llm.invoke prompt dot content. Then we're going to have that finish print statement again. Put it down here, and going to say LinkedIn. LinkedIn generator complete, and we return this guy into its state channel. Have a LinkedIn post. LinkedIn post. Okay. LinkedIn, we're done with the 3. We're done with them. Oof. So let us create our parallel workflow. I need to get out of this function. Let's now create our parallel workflow. I was already out actually. So come here. Let's start building our graph. So I'm going to say builder equals state graph. No, state graph. Overall state. Then we're going to add our nodes. Let's say builder.add node. They're going to be using the same names. So we're just going to pass in the functions. Builder node. Then let's copy this 2 more times. Generate Twitter. Generate LinkedIn. Perfect. So we have our nodes. Now let us build the parallelism. Now, like I said, we are going to start from the start node. We're not doing any preprocessing, so we don't need a node before our 3 worker nodes. So everything starts from the start node. The start node is going to distribute the work to these 3 nodes at the same time. So to do that, you're going to connect an edge between the start node and each of these 3 guys. So say builder.add edge, start, then go to generate Instagram. What's that? Builder.add edge, start, go to generate Twitter. Builder.add edge, start, and go to generate LinkedIn. Yeah, so that's how you perform your parallel operation. If you are not using start, if you're using a node before the parallel operations, this is how you do it. So you just connect from that node to all the worker nodes that you want to send the parallel work to. So we have this, and you can end each of these operations. Probably they are operations that don't return results. They just perform something or cause a change in the environment, and you're okay with them. You can end all of them. You can send all of them to the end node. But we want to aggregate them. We want to gather all of them in a single node. So let us write an aggregator node that is going to aggregate all these operations and compile them into that final report. So let us go up here, just below our LinkedIn node. Let's define an aggregator node. Let's call it aggregate posts. Give it the usuals, overall state, return the overall state. I'm going to tell you to combine all platform posts into a formatted final output. So here we're also going to have a print statement. Just come here, say print aggregator node. What should that? Let's use the clipboard. Yeah, just gathers everything. So we're going to say aggregator, and it's going to say combining all posts. Let's throw in a new line here. Combining all posts. So let us just create a big string that is going to contain all our posts. I'm going to say final output is equals to f string. Then inside here, you can simply build that output. Just going to be a bunch of demarcators for our sections. Say here, give us 70 of those, and the title will be social media content package. Let's copy this, put it under here. Let's have the topic around here. Say topic. Now let's use lowercase letters. Topic, state, topic. Then I'm just going to keep copying this and using it as my title blocks. So for the Instagram, we'll say Instagram post. Instagram post. Then just below it, we'll put our Instagram post. Instagram post. Then, by the way, the aggregator is not going to run until everything is done. The aggregator would run when every of the individual independent nodes are done. That's when the aggregator is going to run. So Instagram post, next is going to be Twitter post. And just below that, we'll have our Twitter post. After that, we're going to have LinkedIn. And below that, we're going to have our LinkedIn post. So that's everything. And we can take this string and just return it to the final output. Final output. Good. So now we have our aggregator node. And to send all our guys to the aggregator node, we'll need to do something similar to this. So here we're going from start to each of the nodes. Now we need to go from each of the nodes to our aggregator node. So from generate Instagram, we need to converge at our aggregator posts node. By the way, we've not added it as a node yet, so let us make sure that we do that, else it won't be recognized as part of our graph. So yeah, aggregate posts. Now I'm just going to copy this and duplicate it 2 more times so that we can take generate Twitter and land it here. Also take generate LinkedIn and land it here. Then finally we can add an edge that will then take our aggregate posts and terminate it at end. Yep, that is everything. That's the construction of our parallel workflow. Now we can compile our graph and run it. So let's say graph equals builder.compile. Builder.compile. Now we have our graph to work with. Let us test it with a topic. Our topic will be the impact of AI on workplace productivity. Let's say we are a productivity influencer. So we want to talk about how AI affects productivity. Yeah, there's like a billion of those kind of content or material online right now. So let's print our topic so that we know the topic that we're working with. Let's step up our emoji game and put a like bullseye. Yeah, so topic. And now we can run our graph. So result is equals to graph dot invoke topic. We give it our topic, and every other thing is just going to be empty. So I'm just going to copy stuff from here, come down here, and just string up everything. So yeah, string, empty string, empty string, empty string. So all our initial states is going to be empty for each of these guys. Something, okay, yeah, I need to have quotes around all this. Okay, let's do this. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now that I think of it, I probably should have just written this out. So yeah, this is all good. We're passing our topic. Every other thing has an initial state of empty. And we can print our results. So print results. Do we really need to print our results? Did we print final output in our aggregate? Let's see. Did we print final output in our aggregate node? Oh, we didn't. Okay, yeah. So we can print our results. So let's just print our results. Let's do final output. So good. Result, final output. Yeah, that's been a lot. Yeah. And that's the thing with this code. We're going to be coding a lot. A whole lot. So yeah. Let us pull up our command line and say Python O2 folder workflows. And I want to run the 0208 parallelization.py file. Hopefully everything goes fine. Enter. You see, it triggered everything at once. Instagram generator. Then Twitter finished first. Oh yeah, that was fast. But we can still see it. We can still see it. Let's go up. So it triggered everything immediately. Instagram generator, LinkedIn generator, Twitter generator. Twitter finished first, even though it appears here as the third. LinkedIn finished next. Then Instagram. And with all that finished, our aggregator combines everything. Social media package. The topic is the impact of AI on workplace productivity. This is our Instagram post, and as you can see, it's using emojis as we instructed it. Emojis all the way. The top text is revolutionizing the workplace with AI, the ultimate productivity boost, and it adds this rocket ship. So adds everything. Imagine a work day, puts a nice rainbow there. And Twitter post. You see, very brief. Twitter, very brief, just uses the rocket emoji. And it says AI is revolutionizing workplace productivity from automating mundane tasks to sparking creativity. Then we have LinkedIn, which is, as you would expect, a bunch of stuff. Just talking and talking and talking. And we have some hashtags here: AI, productivity boost, workplace innovation, professional development, future of work. Let's see. Yeah, Instagram also has some hashtags. Twitter, no hashtag. Yeah. Parallelization. We've been able to generate 3 social media posts targeted for 3 different platforms.